Alright, I got the Renogy 12 volt DC to DC converter down here hooked up in the basement with my 12 volt lithium iron phosphate battery as an input source instead of an alternator here. And then I got these two 12 volt lithium iron phosphate batteries that I'm trying to top balance in the output side. And since I've got a nice steady voltage here, I had a chance to check the efficiency with my clamp meter and a fluke voltmeter. So I check my voltage from these terminals, not the battery terminals. That way you're ruling out any voltage drop in the wires themselves. And then I use a clamp meter, DC clamp meter that I have calibrated to get it as precise as I can and as accurate as I can. What I measured was at 30 amps, 92.3% efficient, and at 60 amps, I got 84% efficient. Now, 92.3 is really good for a DC to DC converter that has buck and boost. 84% is a little lower than you would hope. The manual says 90%. So normally that doesn't matter because you're just driving and you have your alternator going. It's not really a huge issue. At 84%, the input on this side here is 75 amps. So that's not really normally an issue, but I found it interesting that you can get so much more efficiency running at 30 amps. I also checked the standby power. So when the ignition switch is hooked up, which is this side right here, this wire, when that's hooked up to the 12 volt input here, it clicks on a little solenoid inside the unit and you get a 3.3 watt standby power. That's assuming there's no battery on the output side or that the job is done and it's reached the voltage it's trying to reach. When you disconnect the ignition switch, you hear the solenoid click off and the power draw is down to 0. I can't even measure 1 milliamp of power draw. So that's good news because even though there's a battery still hooked up on the input and the output side, you have 0 when you switch off that wire. You also have the other wire here on the left side is the 30 amp selector. So if you have that one hooked up, nothing happens. But when you hook up the ignition switch with that, you get a 30 amp draw instead of a 60 amp or a 60 amp charge. So that's how that works. And then you have your little 5 dip switches over here. Allows you to choose between lead and lithium. And then you can choose pretty precisely the voltage output that you want, depending on how those dip switches are set, which of course you can see that in the manual. Other than that, the unit works great. I have nothing negative to say about it, and just thought that was interesting data. If you guys have any questions or comments, please post them up. Thank you for watching.